yours.
Do we have the lavalier? We'll walk around.
Okay, I can't have you walk too far.
What's that? Oh, like that.
Can't have you walk too far. You can go ahead and screen. But nobody online will see you. So just make a make an appearance in front of the camera every once in a while.
The other way.
Oh.
What?
Your
My
NASA
badge?
badge off?
Just fall apart.
It slides in.
Where is it again? Oh, yeah. Oh, you have the little clicker? Oh. I hear myself and the speakers. You guys hear me okay?
Yeah.
Let's ask somebody to raise their hand.
Well, you can just say next slide now.
I'll just, yeah, I'll trust you next. All right, so I'm Pat Olguin. I'm from the government. I'm here to help you. Before we get started, I'm going to do a selfie here because they asked us to do this. So here we go. Here's our official NASA selfie. And you have to do it right. It has to be a blind selfie. You can't look at yourself. One more. Yeah, I found out my Twitter account got hacked, so I won't be tweeting that until I get home and fix it. Okay. So I stole a little bit from The Hobbit. Those of you guys who are fans of J.R.R. Tolkien recognize there and back again. We can go to the next slide. That's just the title of the thing. So we have 3 goals today. The first one is to understand the problem. The problem is very much analyst-centric here. I'm an analyst. Well, Pat Olguin, I've been working at IV&V since 2001. Worked very closely with Sam Brown and Travis Dawson in the Pasadena office back in the day. And they're here, and I'm still in Los Angeles. Anyway, you can see that in this business, we have 3 competing things that tend to get together. So that's the first thing we'll talk about, understanding what faces the analyst who is trying to support evidence-based assurance in his everyday work. And when I say everyday work, I mean a huge elaborate network of spreadsheets. Okay, so this is definitely, we have rolled back the clock here. Everything else was forward-looking, and we're going back to this is where the analysts are today. And as I'm so excited about that, I actually put the wrong date on my slides, but that's all right. So the next goal, and I think this is the goal of hopefully most of the presentations, is to stimulate discussion. And believe me, I'm open to discussion. I'm going to leave some time for questions. We should get to that. But for the rest of the conference, if you have any other questions, anything, come see me. This really, the work that I did was a one-man show, and it was reviewed by my team leads and selected other sort of Illuminati in the program. And one thing I'm hoping for is we can, look at this sort of proof of concept, sort of an end-to-end test, basically, of whether we can get from here to there, and there being evidence-based assurance using assertion statements, not full-blown assurance cases. You'll see it in a minute. And then hopefully we can find a happy place amidst the enlightenment and relief and shock and so on, and develop even more focused techniques, and as we have like a sort of an iterative approach to this, through feedback through our management and so on. And then the third one is just sort of something that comes up in my own mind as I've done IV&V, which is we hold the project's feet to the fire quite a bit as far as traceability. I mean, it's a big deal, and it's important because in order for them to demonstrate that they have developed a system that's going to answer the 3 questions, right? Do what it's supposed to do, and what I call exhibit preventive behaviors, and then of course then responsive behaviors. That's question 3. I think in IV&V, it really benefits us, and it certainly will benefit both our NASA customer and our projects when we do the same thing. In other words, our work should also be able to be traced, And so I'll show you how that works in the next couple slides. Go ahead. Next slide. Sorry. There, okay, there we go. So we heard a lot about evidence-based assurance. This is just, these are a straight quote out of the manual that we got from Travis Dawson. The middle bullet there is how we do it from the analyst point of view, from the PBRA and from RBA and from the IPEP and TSR. That's all the scoping information that comes down to me as an analyst. I have tools. Some of them are SWOT tools developed by our in-house people. Most of the tools that we use on the GSDO project are spreadsheets. And they're very detailed spreadsheets because one of the jobs we have to do is to analyze every single piece of data that gets transmitted between subsystems in this ground environment and also gets displayed on the launch control system operators' screens. And so every single one of those gets a row in the spreadsheet. And so it's a lot to keep track of. And there really is no halfway method to do this. You have to keep track of every single piece of data that those operators are using because obviously they're controlling people that are sitting on top of a rocket. Okay, and last bullet there. One of the pieces of the assurance and the analysis is the technical reference, and that serves as that's the objective data. It's our understanding of the project's system, and purely in science terminology, the technical reference is a model. It's what we use as part of our analysis. So we hold up the artifacts against this model, and we have our tools and techniques, and we end up with results. Okay, next slide. Okay, this is a very simplified overview of IV&V. It should be familiar to most of you. This is really from the analyst's point of view. We have a project that has high-level material, system specs and so on. That's the project source material. We develop a technical reference, which includes assurance statements, which are really sort of our planning, but and you'll see as I went through this, it becomes also part of my results. It becomes part of a communication tool to get information back to the project and to my management. Also in technical reference, we create adverse conditions, which is, these are the known things that can go wrong during operation of the system, and also characterizations of the system and the software architecture. So that's part of becomes one little bag of our tools. We also have our technical framework tools, catalogs and methods. That's an input to the analysis. And then the actual project artifacts, for the most part, requirements, code, test program, test plans, test procedures, even test results. Sometimes we do IV&V on those. As we saw earlier today, we have people who now we're doing IV&V on security. So the scope of IV&V keeps increasing. And so our results are, the same old thing: issues, risk, reports, analysis worksheets. The analysis worksheets are a huge part of our work because even though you may not necessarily have issues and risks that come out of an activity, the analysis worksheets, that is really a quantitative measure of the goodness. And goodness has always been a word that I hated to hear, because how do I characterize the goodness of a system? Well, if I can demonstrate that, I looked at 5,000 data items in the system, and I didn't find a problem in any one of them. And here is a huge spreadsheet that shows, these were the inputs to this spreadsheet. Here were the tools I used. This was the reference material, and here are the results. Then you actually have a quantifiable measure of the goodness of the system. Here's what we found. Here's what we didn't find. This is all the work we put into this. So this assurance is going to flow back to your management, ideally. Right now, we don't have a way to do that. We end up with the next slide, which is, here's the project view. They give us the high-level reference material. They give us their artifacts that we're looking at, that we're going to do the actual analysis against. And then we return to them a stack of issues, risks, and reports. And the issues and the risks are against their specific artifacts. And so we're providing information about the artifacts themselves, not necessarily, and certainly not, in this case, I don't have a way to provide the assurance without incorporating the assurance cases or insurance statements into my analysis and then feeding the results of this analysis back through that model and then back on the left side up to the project source material, which is basically their high-level view of the system. That's how they view, this is the capability of the system, this is the dependability, all those abilities, that's very important to them. When we just give them a stack of issues, it's like Travis was talking about in his brilliant 2-minute speech earlier. Here's a list of things you need to fix, and when you fix them, we'll know that you fix those things. So there has to be a different path of, there has to be more information, it's got to be characterized differently. Otherwise, we're not going to be able to speak in any sort of quantitative way about the assurance we're providing. Okay, next slide. So here's the analyst problem. I can feed back, in other words, I have, in my results, I have information that says, how did I get here? Well, I got here because I used these tools. I use this analysis from my catalog methods. I use these artifacts, and I ended up with these results. And then that's as far as it goes currently. That's before we started on this little adventure. Okay, so go ahead, next slide. So here's what I don't have. Without being able to relate the actual technical reference material and have it as be part of my work versus something that's developed and used on the side, and I refer to it, and because that has the objective information I need, currently there's no way to feed back the results through that and create a relationship there so that I can go back to the source material that it came from and have something intelligent to say about it, something that's actually quantitative. So this is our problem. And we'll call it a challenge too, because we're working on solving things. So next slide. All right, so anyway, this boils down what I just told you. So my goal here is to make this part of the daily work. And just a little bit of background, we get a lot of support from our management, and we were instructed, thou shalt, even for the established analysis going on, that we're not using the advanced things like the analyst workbench and so on. But we still needed to have adverse conditions, and that's good. We still needed to develop assurance statements, and also software and system characterizations of the architecture. And really just going to focus here, even though we created those other reference pieces of reference material, we're not going to, that would have been a 4-hour discussion, so we had to keep it to 25 minutes. So we're just going to talk about the assurance cases, how we got through it. A huge problem that the analysts complain about, and I worked with we have 13 people on GSDO, and I talked to each one of them individually on what they really needed, what kind of benefit would they need and expect from the assurance statements to apply to their analysis, to just first of all do the analysis, and then what do we have to do to be able to get the analysis results back through our understanding of the system. That's our technical reference, so that we can characterize the assurance. And the biggest problem was, what do we do when we're missing artifacts? That's obviously a gap. And so by being able to just keep track of that and trace back through our technical reference, we're able to at least tell the project in terms they can understand that, look, here, okay, you're behind on this artifact. We know you guys are behind. We don't have to tell you. You can see that you're short on this milestone, but then we can tell you in the more grand terms what this means as far as us being able to provide assurance at this point. Okay, next slide. So my hypothesis: if I can make this hold together logically, informationally, then I should be able to get a quantifiable measure of assurance, which is that's the work we're able to do, and a risk, which is work we're not able to do, and then feed it right back through and directly support this evidence-based assurance that we all want. Okay, next slide. All right, well that's great, but that brings up another problem, and the other problem is that these assurance statements don't just happen. They are it's system engineering, and system engineering, at least in my experience in the aerospace, which has been the last 30 years, is the most difficult job, because that's the deep thinking. I mean, I love it when somebody just gives me, here's a spec, with 8 requirements, and here's how much memory you have to use, and here's your code, and here's, and that kind of thing. Boy, I can march those kind of orders. So we have a lot of we have engineers who can be very smart about finding problems and determining a solution, but doing this kind of work is a huge challenge. And what happens is if you ask 5 engineers a question about, like a concept of operations, you'll get 8 answers. And so that was a big challenge for us. One of our goals here is to is when we come up with this assurance, just assurance statements, and then in particular, and thank you guys, your panel, by the way, stimulated quite a lot of thought for me, and that's why I'm moving around quite a bit in my mind, is that the industry right now, when they talk about assurance, it's really talking about safety and dependability. But we have safety and dependability is, of course, a huge part of the systems that we assess. But we also are assessing, are they going to accomplish all of their mission goals? Because even though the spacecraft may not burn up in orbit or something like that, or the astronauts are safe, there's still a lot of science that has to be conducted, and all of that, almost all of that, are the nominal conditions. And so that also has to be included in this part of the assurance, because we need to be able to tell the project, yeah, your fault systems look great, but are you going to get the science data that you want? So well, then you have my editorial comments at the end. What happens is or it can happen, is it ends up being at worst case, is a square filling exercise. And so when I was given this task back in February or so, we and my management agreed that we were not going to let this just become a square filling thing. We really wanted to be committed to having this part of the technical reference be an essential part of our work. So we signed up to it, and that's what we tried to do. All right, next slide. Any questions? We could do it right now. You have one free question, anybody? Okay, we'll keep going. All right, so the next hypothesis, therefore, if the analyst can be provided with a concrete example of how you actually do this and write an assurance statement, then if I get a couple of good ones and we can brief the people, then we can roll this thing out and we can improve their ability to get on board with supporting evidence-based assurance. So that's my second hypothesis. Okay, next slide. Okay, so here's our benefits. Living document, right? We've heard that phrase ever since college. And so, and that wasn't just a goal for me, that was a hardcore requirement. I mean, and for it to be a living document, it has to truly be a part of my every single time I go to do a little piece of analysis, my reference material has got to be right there, in a dashboard. And now I didn't have a lot of time and budget to do this, so we did what we do best on GSDO, which is we developed another spreadsheet. So that was just for you, Nova. So anyway, and then like I said, another goal, and it was a software requirement. It was more like a wish. Was that our set of assurance statements ended up feeling like it was a single voice, not necessarily like an automaton spitting this stuff out, but we didn't want it to seem like it was 13 Indians went off and did their own thing. So the bottom goal out here with the low-level results, that hasn't, all the information is there, and I was able to do it sort of in a manual process, but that is definitely a just slightly longer-term goal, is to be able to automatically go through your spreadsheets and with a macro or two, and roll up your results, and roll it up right through your references to your technical reference material into quantified statements about what's going on. Okay, next slide. All right, so I'm not going to read all the methods. This is you can look at this, kind of offline. But we went through and created, okay, like I said, yet another spreadsheet. I actually did a user's guide. We're not going to talk about that today. That would be like another 2-hour breakout session. I created 2 end-to-end examples using our elaborate spreadsheets, and also including adverse conditions, and 2 sets of assurance statements for 2 different subsystems, and briefed those all to our team. And when their heads stopped spinning around, a lot of people thought that this looked like a good idea. It also looked like a lot of work. So one of the right at the bottom of the method, the incomplete delayed analysis was easily identified by empty cells in the spreadsheets, and that's a big payoff where you don't have to go hunting around for what's missing. I mean, it becomes plain, and it's sitting there looking at you every day, right in the middle of your work. It's not something that just gets pushed off to the side. Okay, next slide. So this is really just my gratuitous bragging slide of the system I get to work on. It's actually quite a privilege to be able to work on the manned mission. The ground system development operations program is immense. There's hardware and software all over KSC. I don't know. I got to visit KSC about a month and a half ago. It was my first trip there since 1970, so a lot has changed. Although the VAB really hasn't changed that much on the outside. They added a new painting, but there was a lot of familiarity. Just a few highlights from the system. They're doing a lot of modernization of their hardware. They're also keeping hardware and then updating it, with new software, new firmware. The main areas that we're looking at are the launch control center and local displays that the operators use. Those displays control PLCs, programmable logic controllers. And so you have, and I'm really not that good at ladder logic. I'm going to take a little ladder logic class later this week. Just a little more background on that. These displays they're emulating the very old tab displays that anybody who's ever seen an old air defense console or air traffic control thing would look familiar. It's not a windowing system. They are tabs that you push, and so these are sort of virtual tabs that the operators use. The reason that it's kept so simple is because just about every piece of hardware that's controlled by these displays is life critical. We have cryo systems with liquid hydrogen and liquid oxygen, leak detections, for fire and leak detection, range safety, power, of course, is a huge system at Kennedy Space Center, and then the emergency safety system, which is basically where all of the subsystems feed in their safe data into a central and completely separate system to keep things cool during an emergency. The code I stuck at the bottom is from one of our project customers, and they are very proud. They really do embrace IV&V, and they tell anybody who listens that IV&V does what we can't, which is we go through the painstaking details that the development projects just can't do because they have to keep marching towards their deadlines. So even though we're independent, they very much depend on us, and that's good to hear from your developers instead of the usual pushback that we can get sometimes. Okay, next slide. All right, so this is I redacted anything that's remotely ITAR or sensitive but unclassified. So I made up a thing called a leak detection system. This is an example of where our first insurance statements look like. They are very generic looking. Every single top-level claim read exactly the same. Will operate safely when performing, on the pad and nominal and known adverse conditions. And to me, that seemed to be limiting. It didn't seem that was going to support my analysis. So I thought we need to be more specific. Next slide. Also, the problem with that. Well, let's go back one. Let's go back and look at that for a second. So if I'm looking at the overall ground system, and the ground system it's a spaceport, right? That's in case people don't know what the GSDO. GSDO is essentially Kennedy Space Center's spaceport, and it's the mobile launcher. It's all the software and hardware required to launch a spacecraft. We don't launch space shuttles anymore, but we're going to be launching SLS, also other commercial vehicles. So that is what needs to be supported by GSDO. So now we go next slide. So the problem I saw right away with that assurance statement was that it seemed like it was too low level. I mean, it was just about this display. And the scope of the ground systems, of course, is much bigger than just one operator looking at one display. So that was my first knock against it. A huge functionality of the ground systems at Kennedy are their test and checkout. So much work on test and checkout. And that was why I asked Joelle earlier about IV&V of the development environment, because this is all really one continuum. There's no concept that the development environment is somehow distinct from the operational environment, because it's all together. So if you have some sort of compromise in the development environment, you could have a compromise, in your live system, because this stuff is all happening in the same area. Boilerplate statements didn't really add any value. If you notice, that looked like that's just a Microsoft Word. Since we're doing everything in spreadsheets, it's interoperability there is kind of a challenge. So, next slide. Okay, so here's my this is my big solution. Let's build another spreadsheet. So I'm not going to read all the features, but we'll go through them really quickly, and you'll see that it definitely is it added the bells and whistles, not the bells and whistles, it answered the bare requirements that I had to have to be able to have this whole thing hang together from the top, from the project, top level documents to my results and back again. And also just there's a kind of motherhood statement there at the bottom. Okay. So here we go, and I don't have a pointer, but I'm going to walk over here. So at the top, those of you who have done insurance cases, that should look familiar. There is a top-level claim. And you see my notation, it comes straight from ConOps. So I just reworded a few things. Of course, this is my imaginary ConOps, right? This is not from an actual SBU document, so make sure that's, that's clear. And so I was able to, there's a little bit of a trickery to put ConOps words into top-level claim verbiage, but with enough examples, people begin to get it. So anyway, so that's where we start. We start at the top. We come straight out of our ConOps. This is much higher level than just an operator's display. Okay. So and this way, if you've done assurance statements, the first column here, the first column should look familiar. Okay, go ahead. Next slide. So next, over there I have a link to the TSNR. So that's the TSNR for the GSDO. And so if I want to look at that document, because it has all the scoping and rigor for my work, I could have it on my desktop somewhere, but given that those of you who work with ECM and other data stores here, that going into the depth of the directory isn't all that much fun. So I just made a convenience here. Here's your TSNR document. But here's the one that you actually used to generate or to support this assurance spreadsheet here. Okay, next. And anybody else who is familiar with the TSNR, you'll see that's a row from my subsystem I'm working on here. From this, this is the ground main propulsion subsystem. So I thought that document was just too big to have to thumb through when I'm doing my work, and so I just there's a tool called Snippet, which is part of Microsoft Office that you can use it to clip anything you want and stick it. And I just stuck it here right in the cell of my spreadsheet. So there's my handy reference, right in my little spreadsheet dashboard. Okay. And by the way, that's a living document, by the way, right? The TSNR doesn't just sit there. It's changed. It changed because it's subject to budget and schedule and so on. Matter of fact, all the GSDO people are rereading our TSNR because it changed, I believe, yesterday. So you would go and update this thing. Okay, so looking at the spreadsheet, I have a column here that says SW, that's software. So each of these rows here is supporting statements to my top-level claim. These are functions in this subsystem. It's a huge subsystem. So I've broken these down, and since I grabbed them right out of the ConOps, not all of them are software, but I still want to be able to. I want to track these things, because I want the customer to know, both the project and NASA, to know that I looked at all this stuff, even though I'm not going to analyze it. It's important I know, so that we can document the assurance we're providing. It's important that that I had a look at this stuff, even if it's not in scope. And so what I call this is question 2 for IV&V. In other words, it's important for us to not do what we're not working on, but you still have to document. I think it's important to recognize what is the scope of the system, even though I'm not necessarily going to analyze it. So this is just an easy filter in my spreadsheet, and these are all the yeses. I left off the hardware and procedural stuff, but it's still important for us to know that. Otherwise, we're not going to be able to speak intelligently to the project to convince them that we have a convincing case that their thing's going to work. Okay, next slide. So here's a link to the ConOps itself. One click, boom, you got a document if you want to look at it. Next slide. And then you actually can have a one-to-many relationship here. I don't have any open TIMs because, like I said, this actually was culled from a real sheet that I used. I don't have any open TIMs. This here, I X this all out because this was going to be SBU and ITAR material. I just because it's a lot of work to build up this spreadsheet from a ConOps and from the high-level documentation, because I mean this is system engineering. You have to think, and so I include the original text here so that when I go back up one slide. So that because I'm creating these claim type phrases on this side, I still want to have original text potentially. I can always hide that column to just so I know where I came from. Important thing. Okay, go ahead and go back. Next slide. So we have a place for the TIMs. Also, sometimes I don't understand what I'm working on, and so I'll go call the developer, I'll email them, and I'll say, you know what, if I got this right, is this really what we're talking about? And so I'll have a little note there for project concurrence. Next slide. So this could be done in a database, and so Don Kranz and company, if we could, when the workbench is available, this stuff can go right into it, because we've got a major key, which is the section number of this document that it came from, and then we have a minor key, which is the actual requirement number. And then back, let's see here. Oh, and this, by the way, so now, yeah, it's such a big screen. This is the actual analyst worksheet we jumped into, okay? We're not in the assurance statements anymore. And so then back across in the huge column, you can see we have a lot of detail in these spreadsheets. And so I just added one column. That's all I had to change to the analyst spreadsheet to make it work with this. And I just inputted a yes, saying yes, this is linked to an assurance statement. And the yes, of course, is actually a hyperlink back to the assurance statement where this came from. And then you can look at, I have sort of an anomaly on row 6, which is I haven't, at that point I had not found the software description for that particular requirement. So this thing is updated constantly as you're finding more and more about your system. Okay, next slide. So this is we've shifted over in this worksheet. There's you can see there's the link on column W to the assurance. And now in my actual analyst spreadsheet, if there's a requirement that's got an issue against it, I put the issue in there, and that's a link currently into Orbit. And so if I click on that, it takes me right to the issue. So I can see what the result was on that side. And I had to redact these, but I actually take the issue description and I grab it from Orbit and just stick it in there. I mean, it's one little redundancy of data, just because obviously the issue number isn't going to tell me that much about this the problem with this requirement necessarily. And then, and you can see on the bottom right-hand corner, that's actually a note. If we scroll back, go back one slide, Jennifer. That's the one that's highlighted in 6. We haven't been able to find that artifact yet. So you would see that notated in our worksheet, in our analyst spreadsheet. Okay, I'm going to go ahead 2 slides now. All right, so we achieved our goal here. I mean, our short-term goal, definitely, which is I have a way, just by changing that analyst spreadsheet by 1 column, because I did all this other work ahead of time in creating this assurance statement that has the information that leads back up to the ConOps and back to my source documents. I was able to, I now can go back and relate my issues back to their technical reference and then characterize it in the format and the terminology that the project likes. Okay, next slide. So we've got a bidirectional tracing of our assurance evidence and statements, and as you saw, just minimal impact to the current spreadsheet, just 1 column. Now we added a whole new spreadsheet. That's just well, we can't back up. We're not going to back up that far. We added that first spreadsheet. That was a whole new spreadsheet, and that is actually admittedly a lot of work. That's the second thing. It's very time intensive. There's no halfway to it. In other words, you either have input all the information and know all the answers, or you don't. And so I mean, it's like every other IV&V task that we do. It's labor intensive because we need to be exact. So I alluded to this earlier. Still lots of features to add. This automatic roll-up would be nice. Would be nice. The other thing it does is give that where we have in our spreadsheet, if everything is in the green, then we have a quantitative measure of goodness, or at least a number we can give to the project and say, you know what, we looked at your 5,000 sub requirements for your display, and all of them were good. And so this particular display, we can tell you is going to work. The tracing and this sort of structure that I put together, it'll work for your test program because that's also driven by requirements. So we can do the same thing. We can go to the paragraph in the document, get your requirement number, go to your test case, get the results, and then come all the way back the same way, same direction. And as I said, it could be implemented in a database. Matter of fact, I think it would be better in a database, but it was a lot less expensive, I think, to at least do a proof of concept in spreadsheets, just so that we could show that, build basically a relational database in our spreadsheet. And the proudest moment of this whole thing is that we were able to support the evidence-based assurance directly without completely redoing the way analysts who are their boots on the ground in a lot of documents right now on GSDO. And I think that's it. There's only 28. How are we on time?
You are out of time.
Oh!
We've taken up all the
next slide. We'll just got my email on there. Wait.
That's actually, there are no more slides.
Oh, I didn't get. Well, anyway, acknowledgements. Travis Dawson and Sam Brown were big helps on this. And then if you want to contact me, patrick.m.olguin@nasa.gov. And we'll talk more about the magic. And of course, we'll talk more later during the conference. Thank you.